Hello, my name is Jeisson Parra, and today I'm going to present the paper review titled Deep Neural Networks Correlation Learning Mechanism for CT Brain Tumor Detections. This paper focuses on using deep learning, specifically a model called CLM, to improve the tumor detection in brain CT scans. I select this paper because it connects directly to our proposal project, develop a deep learning method to early stage brain tumor detection. In the background and motivations, we have that the motivation behind this work is the growing opportunity of applying computational technologies to medical diagnosis. In previous studies, they showed that deep learning can detect, for example, brain tumor hemorrhages or some disease from the lungs, especially in CT scans, which inspired them to extend these methods to detect tumors in the brain. So the author's main goal was to develop the correlation learning mechanism, or CLM, that improves how the CNN selects and applies the filters, making the tumor detection more precise and efficient. The methodology that they apply was basically with the CLM model combining the two neural networks, the CNN and ANN. In the first step, the CNN extract the image features using multiple filters that they explained there, such as gradients, Laplacian, and high pass filters. And in the second step, with the ANN, they evaluate these outputs and select the best filter configurations, which the authors call here a palette. In the CNN, they reconfigure each iterations based on which palette give them the best accuracy and the lowest itself. And at the end, the model was trained using the multi-thread processing with the Adam optimizer to increase the speed and efficiency. The general idea of the parallelization is that they generate a random set of palettes to examine it, the first iterations, and then the palettes were generated fully random. While in the next generation, each palette gives a best solution in the data set. So what they obtain is that using the data set they use two main data sets, one from Kaggle CT datasets with over 338 images, and the second from Chen et al. Dataset with over 3,000 tumor images. So their model CLM achieved excellent results, around 96.5% the test accuracy on the first dataset and 95% on the second, with high precision and recall. Another key benefit was the faster training compared to the TensorFlow-based CNNs, and thanks to their multi-threaded design. This is because of their multi-threaded design that they use it. And the specified was around 97%, meaning few false positives. So what I identify here as a gap that I can include in my project is that even though the CLM architecture has a high accuracy, the authors didn't notice the more heterogeneous or real-world datasets, which don't evaluate also for early-stage tumor detections. And in clinical practice, the early detections, especially for very small tumors, it's crucial for improving the patient's outcomes, like survivance. So these gaps represent an opportunity to extend their work. And in my proposal extension, the goal will be improve the model using early stage with small lesions detection, using for the CT scans only, increasing the sensitivity for smaller tumor detections that over 5 millimeters, while keeping their model efficiency. So the first step will be like have a more diverse CT datasets from their sources. And also I would like to apply a denoising and normalization to make the small tumors more visible. In the second step, I will use a grand cam that will give us planability and technique that generates the heat maps showing where the model focus, so everyone can identify where is the tumor, improving the interpretability and truth for the radiologist. And I finally evaluate the model sensitivity across in the different tumor size, expecting similar metrics as they obtain with high sensitivity for small tumors. And for closing, in summary, this paper introduced the dynamic CNN and ENN framework that optimizes itself through the policy selection mechanism. With my proposed work aims to extend the idea, focusing on early detection using enhanced preprocessing and explainable AI. Thanks you for listening.